In section 6, we're going to talk about multiplying and dividing radicals. So in section 5, we talked about adding and subtracting. So now we're going to talk about multiplying and dividing. And dividing is in quotations here because it's not like dividing like you've seen before, like when we're dividing polynomials or even dividing with fractions. It's a little bit different. So we're going to start with multiplying radicals, and when you are multiplying radicals, you follow the same rules as you would if you're multiplying polynomials. So you use the distributive property in FOIL. And as long as the radicals are the same index, which means both square roots or both cube roots or so on, you can multiply them. And then once you multiply, you do want to check to see if the new radicals you have can simplify in any way. So for our first example here, we have the cube root of 2 times the cube root of 4 plus the cube root of 12. So what we're going to do is we're going to distribute the cube root of 2 into both of our terms in the parentheses. So you get the cube root of 8, because 2 times 4 is 8, plus the cube root of 36, because 12 times 2 is 36. Now I have to simplify those cube roots. So 8 I can break down as 4 times 2, and 4 breaks down as 2 and 2. And because this is a cube root, you're looking for 3 of the same number. So I have 3 2's. This should say 48, not 36. 24, 12 times 2 is 24. So I break down 24. I'm going to break it down as 8 times 3. And then 8 breaks down as 4 times 2, and 4 breaks down as 2 times 2. So I have a group of 2's here as well, and then I have a 3 left over. So the cube root of 8 just becomes 2, nothing left underneath the radical, plus, and then I do have a 2, and then underneath my cube root I have a 3. And that is going to be the final answer. Second type of example is if you're multiplying two binomials. So that means you have two terms. So we have 2 plus 3 square root 7 times 4 plus square root 7. So everything in the first set of parentheses is going to multiply to everything in the second set of parentheses. So we're going to start with 2 times 4, which is 8, plus 2 times radical 7, which stays 2 radical 7, because they're not both underneath the square root. Then you have to do the 3 square root 7 times 4 and the 3 square root 7 times the square root 7. So 3 square root 7 times 4 is 12 square root 7. And when I do 3 square root 7 times square root 7, I get 3 square root 49. So now I want to work on simplifying radicals and combining like terms. So the square root of 7 cannot simplify, but the square root of 49 can. Because 49 is 7 times 7, so that's a pair of 7's there. So I end up with 8, and then 2 square root 7 plus 12 square root 7 is going to give me 14 square root 7, plus, and then that 7, when I simplify the square root of 49, has to multiply with the 3 that's already there, that gives me 21. Now I can combine 8 and 21. So I get 29 plus 14 square root 7. And that's the final answer. Next we have negative 2 minus 3 square root 6 squared. So similar to when we had polynomial multiplication like this, I can't just distribute the squared into my parentheses. I have to expand it. So I have to write this as negative 2 minus 3 square root 6 times negative 2 minus 3 square root 6. And then I'm going to go ahead and use my distributive property like we did in our previous example. So negative 2 times negative 2 is going to be 4. Negative 2 times negative 3 square root 6 is positive 6 square root 6. Then negative 3 square root 6 times negative 2 is positive 6 square root 6. Then negative 3 square root 6 times negative 3 square root 6 is positive 9 square root 36. So the square root 6 can't simplify, but 36 is 6 times 6, so I have a pair of 6's there. So I get 4 plus 12 square root 6 plus, and then 9 times 6 is 54. And then 54 plus 4 is going to give me 58 plus 12 square root 6. And that is the final answer. Now we're going to discuss dividing radicals. So when we are dividing radicals, we're not actually dividing in the sense that you are getting a simplified fraction or a decimal, or like in dividing polynomials, you're getting an expression. What we do when we're dividing radicals is get rid of any radicals in the denominator of our fraction. So we're basically rewriting it so that you no longer have radicals. And we do that by a method called rationalizing the denominator. And there's two types of rationalizing the denominator we're going to look at. When you have a single radical expression in the denominator, and when you have a binomial radical expression. So we're going to start when you have a single radical expression. So when you rationalize the denominator, you are multiplying the numerator and the denominator by the radical that is in the denominator to get rid of the radical. We're only going to be dealing with square roots here just to keep it easier. But if you have a cube root or fourth root, it's not as simple as just multiplying by the radical in the denominator. But we're going to keep it simple and just deal with square roots to make it a little bit easier. So in our first example, we have 1 over the square root of 2. So if I want to get rid of the square root in my denominator, I'm going to multiply my numerator and my denominator by the square root of 2. So 1 times square root 2 is still square root 2. And then square root 2 times square root 2 gives me the square root of 4. Now I want to see if I can simplify any of my radicals. And the square root of 2 can't simplify, so it stays square root 2. But the square root of 4 is 2. So I end up with the square root of 2 over 2. And that's as simplified as it gets. In our second example, we have 12 over the square root of 28. So I'm going to multiply the top and the bottom by the square root of 28, which is going to give me 12 square root 28 over just 28. So another shortcut you can kind of notice here is if I multiply a radical by itself, so square root 2 times square root 2, square root 28 times square root 28. We even saw in our multiplying examples, you just get what's underneath the radical to start with. Because when you multiply a radical by itself, you cancel out this radical and you just get what's underneath. Okay. So at this point, I need to check to see if my radical simplifies at all. So I need to simplify the square root of 28, which I'm going to break down as 7 times 4. And 4 breaks down as 2 times 2. So I do have a pair of 2's. So this is going to become 24 square root 7 all over 28. Now I want to see if what's in my denominator can simplify with the number that is outside my radical. And 24 and 28 are both divisible by 4. So we're going to get 6 square root 7 all over 7 as our final answer. Now you cannot simplify what's underneath the radical with anything that is outside the radical. So you can't simplify that square root 7 with that 7 that's in the denominator. We can't do that. Then our last example, 5 square root a over 3 square root 5b. So remember, I only have to multiply my numerator and my denominator by the radical that's in the denominator. So I don't actually have to multiply by 3 square root 5b in the numerator and denominator. I can just multiply by the square root of 5b. Because I only care about canceling the radical. So my numerator is going to become 5 square root 5ab. And the denominator is going to become 3 times 5b, because those radicals are going to cancel. So you can do one of two things. I can go ahead and multiply my denominator here, and I'll get 15b. Then I have to check to see if it simplifies with the numerator. Or I can go ahead and notice right now that my 5s are going to cancel here. And I'm left with the square root of 5ab all over 3b. Because the 5 isn't going to simplify, and I don't have enough a's or b's, because in order to simplify variables underneath the square root here, I'd have to have at least 2 of them. So I don't have enough variables to simplify. If I had to go ahead and multiplied first in my denominator, I would have gotten 5 square root 5ab all over 15b. So now I still would have simplified 5 and 15 by dividing them both by 5. So I still end up with the exact same answer, but now I've done it in one less step than before. The second type of example that we're going to look at is rationalizing the denominator using something called a conjugate. So this is specifically used when you have a binomial radical expression. So that means you have a number plus or minus a radical or vice versa in your denominator. So what we do here is we multiply the numerator and denominator by the binomial expression in the denominator with the opposite operation. So we're not multiplying the numerator and denominator by the same thing that's in the denominator, but the one with its opposite sign. So for example, if I have 1 plus the square root of 2 in my denominator, its conjugate, so what I'm going to multiply the top and the bottom by, is 1 minus square root 2, because the opposite operation of addition is subtraction. So you only change the operation between your number and your radical, not the operation of not the sign of every term. So let's do a couple examples. So our first example is 2 divided by 3 minus radical 5. So what I want to do is multiply my numerator and my denominator by my conjugate. So the conjugate of 3 minus square root 5 is 3 plus square root 5. And what you want to do here is treat this 3 plus square root 5 like it's in a set of parentheses. And you want to distribute like we did when we were multiplying in the first part of the notes. So I have to do 2 times 3, which is 6, plus 2 times square root 5, which gives me 2 square root 5. And in the denominator, I have to use FOIL. So I have to do 3 times 3, which is 9, 3 times square root 5, which is 3 square root 5, negative square root 5 times 3, which is negative 3 square root 5, and then negative square root 5 times positive square root 5, which is going to give me negative 5. Now if I notice, in my denominator, my plus 3 square root 5 and my minus 3 square root 5 are going to cancel. So my numerator is 6 plus 2 square root 5 still. And in my denominator, 9 minus 5 becomes 4. So now I only have a single number in my denominator. I no longer have any radicals. And my last step is to check to see if the numbers that are outside any radicals can simplify. So in this case, that's 6, 2, and 4. And 6, 2, and 4 are all divisible by 2. So if I divide everything by 2, I end up with 3 plus the square root of 5 all over 2. That is my final simplified answer. The last example we're going to look at says 3 plus the square root of 2 all over 6 minus the square root of 2. So if you have a binomial radical expression in the numerator and the denominator, we still multiply by the conjugate of what's in the denominator. It doesn't matter what's in the numerator. So my conjugate here that I'm going to multiply by is 6 plus square root 2 over 6 plus square root 2. Again, we want to treat this as if it's in parentheses, and we're going to have to use FOIL in our numerator and our denominator here. So we'll do 3 times 6, which is 18, 3 times the square root of 2, which is 3 square root 2, square root 2 times 6, which is going to give us 6 square root 2, and then square root 2 times square root 2, which gives us plus 2. In our denominator, we're going to use FOIL as well. So 6 times 6 is 36. 6 times the square root of 2 is 6 square root 2. Negative square root 2 times 6 is negative 6 square root 2. And then negative square root 2 times square root 2 is just negative 2. So in my denominator, the positive and negative 6 square root 2's are going to cancel. In my numerator, I have some like terms. So 18 plus 2 is 20. And 3 square root 2 plus 6 square root 2 is going to be 9 square root 2. And in my denominator, 36 minus 2 is 34. Now I check to see if 29 and 34 can simplify by anything. And they can't, because the only thing that goes into 9 is 9 and 3. And neither of those numbers go into 20 or 34. So I don't have to simplify it any further. And that is my final answer. Let me know if you have any questions about multiplying or dividing with radicals.